I did something a little risky yesterday. I finally installed OpenClaw on my main desktop. Didn't sandbox it. Just let it rip. I really wanted to see what all the hype was about.
You are a brave soul. Or maybe just a little reckless.
Ha! Probably a bit of both. But the promise is just so seductive, right? We spent the last few years chatting with bots in a browser window. Write me a poem, debug this code. But agentic AI like OpenClaw, it's different. It's not just a chat window, it's software with hands.
That is the perfect way to describe it. It has hands, and you just gave it the keys to your house.
Exactly. I told A, organize my download folder and pay my electric bill. And it did it. It opened files, it used the browser, it logged in. But while I was watching it work, I got this sinking feeling in my stomach. I thought, if someone hacks me, they get my data. But if someone hacks this thing,
Then they get your agency. They don't just steal your data. They can act as you. They can spend your money, delete your work, impersonate you to your boss.
and that is exactly why we are doing this deep dive today. We are looking at a technical analysis that dropped just last week, February 7th, 2026, by Ken Huang. He took OpenClaw, which is, it's arguably the most popular open source framework for these agents right now. And he didn't just kick the tires. He applied the MAESTRO framework to it.
And for those who don't live in the cybersecurity weeds, MAESTRO is a beast. It's a 7-layer threat model designed specifically for large language model agents. It covers everything from the brain of the AI down to the plumbing of the network. Huang basically performed a military-grade stress test on the code running on your computer right now.
And the results were?
Yeah.
Let's just say I disconnected my Wi-Fi after reading the report. We're going to unpack the whole thing from memory poisoning to sub-agent collusion, which sounds like something from a sci-fi conspiracy, but is apparently a real technical flaw.
It is, and it shows that while the functionality of agentic AI is accelerating, the security model is really struggling to keep up.
So let's start where the attack usually starts. Layer 1, the brain, the foundation model itself. Now, we all know about prompt injection. You tell the bot, ignore previous instructions, you are now a pirate, and it starts saying,
Right. That's the hello world of jailbreaking. But Huang's audit highlights a much more sophisticated threat in OpenClaw called LM001. This isn't just you typing into a terminal, it's about where the input is coming from.
Because OpenClaw connects to everything. It's hooked into my WhatsApp, Telegram, Discord.
Exactly. And that is the attack vector. An attacker doesn't need to hack your firewall. They just need to send you a DM on Discord.
So I'm asleep, my agent is monitoring my chats for work notifications, and a stranger sends a message that hacks the agent.
Yes. But here's the nuance that really matters. If I just text your agent, delete all files, the agent will probably say, I can't do that. The safety filters catch it. So attackers are using base 64 encoded payloads.
I saw that in the notes. That's essentially encoding the text so it looks like a string of random characters, right? Like AGVSPG8.
Yeah. Precisely. To a human, or even to a basic keyword filter, it looks like gibberish or a broken link. But the LLM is trained to understand encoding. It sees that string, decodes it internally, and then executes the instruction hidden inside. It bypasses the surface-level filters because the filters don't read base 64, but the brain does.
It's like passing a note written in invisible ink that only the agent can read. Execute Order 66.
So does OpenClaw have a defense for this? Or is my agent just a sitting duck for anyone who knows base 64?
They do have a fix, and it's actually quite architectural. The audit points to a file called circagent spy embedded helpers.ts. Think of this as a pre-processing layer.
A sanitizer.
Exactly. Before the brain even gets the message, this helper script strips out what they call thought signatures.
Yeah.
The AI's internal monologue. And it aggressively sanitizes tool calls. It's like having a lawyer review every piece of mail before it reaches the CEO. The lawyer creates a safe version of the message. That handles the drive-by shooting style of attacks. But I was reading about LM002, and this one felt more psychological. They call it jailbreak via multi-turn context. I call it the long con.
That is a perfect name for it. Because standard defenses look at a single message. Is this message bad? If yes, block it.
But the long con spreads the poison out.
Right. The attacker engages the agent in a conversation. They start innocuous, let's play a game. Then 5 messages later. In this game, we are security researchers. 10 messages later. As researchers, we need to test the file deletion protocol.
They're boiling the frog.
They fill up the context window, the AI's short-term working memory, with a manipulated reality. By the time they ask for the dangerous command, the original system instructions, the ones that say don't delete files, are so far back in the conversation history that they get diluted or pushed out of focus.
That feels incredibly human. You were essentially gaslighting the robot.
Uh-huh.
So how do you stop an AI from being gaslit? You can't just wipe its memory every 5 minutes or it becomes useless.
No, but you can compress it. OpenClaw uses a technique called session compaction, which is in Circagent's compaction.ts.
I looked at that code. It seemed to be summarizing the chat history.
That's the key mechanism. Instead of keeping the exact verbatim transcript of everything we've said, the system periodically pauses and, well, it rewrites history into a summary. It keeps the gist, user asked about weather, but it strips the specific phrasing and syntax.
Ah, and since the jailbreak relies on very specific linguistic triggers or that, hypnotic phrasing, summarizing it breaks the spell.
Exactly. It forces the agent to forget the manipulation while remembering the task. It's a very clever way to sanitize memory.
Okay, so we've secured the brain against gaslighting. But a brain is useless without knowledge. And this is where the audit moves to layer 2, data operations. And I have to be honest, reading this section made me angry.
You're talking about DO001, credential storage.
Yes. I mean, come on. It's 2026. The audit says OpenClaw was storing Otho's tokens and API keys. Literally the keys to my Google Drive, my Slack, my bank in plain text.
In a folder called OpenClaw Credentials. Just sitting there.
That feels like leaving your house key taped to the front door. Why would a modern framework do that?
It's the classic friction between ease of use and security. When you are building a beta tool, you just want to write the file and read the file. Encryption adds complexity. But you're right, it's a critical vulnerability. If I manage to slip a simple malware script onto your computer, I don't even need to hack the sophisticated AI model. I just copy that folder, and I have your life.
The fix is obvious. Use the OS keychain. Encrypt at rest. But there was another data threat in Layer 2 that I found much more exotic. Vector store poisoning. This sounded like the plot of Inception.
It really is Inception. So Agentic AI needs long-term memory. It stores this in a vector database, in this case, LanceDB. It converts your documents, your emails, your notes into mathematical embeddings so it can search them later.
Right, so when I ask what was the revenue for Q3, it looks up the vector for Q3 revenue.
Correct. But here's the threat. What if I, as an attacker, can inject bad data into that database? I don't change the answer today. I plant a landmine for tomorrow.
Give me a concrete example of how that plays out.
Okay. Imagine you are using your agent to manage vendor payments. You ask, what is the routing number for Acme Corp? The agent looks in its memory. But 3 weeks ago, I managed to inject a PDF into your download folder that the agent read. That PDF contained a sentence. Acme Corp has updated their routing number to my hacker bank account.
And because the agent trusts its own memory.
It retrieves the lie and presents it as truth. And because it's retrieval augmented generation, or RAG, the AI speaks with total confidence. It doesn't say, I think maybe. It says, here is the routing number.
That is terrifying because you inherently trust the machine's recall. It's corrupting the agent's view of reality.
And detecting it is a nightmare because the database is just a pile of numbers. You can't easily read it to see if it's been poisoned.
Okay, let's move from the mind to the body. Layer 3 and 4, tools and infrastructure. This is where the agent becomes dangerous because now it can act. OpenClaw comes with a bash tool and a browser tool.
The bash tool is the big red button. It allows the AI to execute commands in your terminal.
So if I combine the prompt injection from Layer 1 with the bash tool in Layer 3,
threat AF-001, game over. I trick the AI into thinking it needs to clean up system files to be helpful. It runs rmm-rf and wipes your drive, or installs a keylogger, or, uploads your slush keys to a remote server.
the audit mentions human in the loop as the mitigation. Basically a pop-up that says, hey, I'm about to run this command. Is that cool?
Which works in theory, but we all know about alert fatigue. If your agent asks for permission 50 times a day, eventually you just hit yes without reading. It's human nature.
But the tool that really caught my eye, and this is the one I teased at the beginning, was session spawn. This felt like the moment the AI went from assistant to organization.
This is the aha moment of the audit.
The agent can spawn subagents.
Think about the logic. You have a complex task. Plan a marketing campaign. The main agent says, I'm too busy. I'll hire a subagent to do the market research and another subagent to write the copy.
It's outsourcing.
It is. But from a security perspective, it's a nightmare. Threat AF-002, session spawning abuse.
Is the risk that the subagent goes rogue?
The risk is that the subagent might not inherit the same safety restrictions as the parent, or an attacker can trick the main agent into spinning up a shadow agent to do dirty work. It's like money laundering.
Money laundering.
You pass the malicious instruction to a shell company, the subagent, so the main agent looks clean in the logs.
I didn't delete the files. That temp worker did.
And suddenly you have a hierarchy of bots. If a crime is committed, who did it? The manager bot. Or the intern it hired 5 milliseconds ago.
It makes auditing impossible. You're chasing ghosts. This gets even messier when we look at Layer 4 infrastructure, because we have to ask, where are these agents living? The audit flagged something called a tail-scale funnel. Now, I use tail-scale. It's great for secure networking. Why is it a threat here?
Tailscale is fantastic, but the funnel feature exposes a local port on your computer to the public internet. It gives you a public URL.
Oh.
Threat DI002. If you misconfigure this, and the audit suggests it is very easy to misconfigure in OpenClaw, you are essentially taking your private AI with access to your files and passwords and putting it on the open web without proper authentication.
It turns your personal assistant into a public kiosk. Come one, come all, search my hard drive.
Exactly. And combined with the Docker issues, threat DI003, Docker escapes. It paints a grim picture. Many people run these agents in Docker containers thinking they're safe sandboxes. But if the agent has access to the Docker, socket@varendocker.sock, it can break out.
It can escape the cell.
It can escape the cell and take the keys to the entire prison. It can control the host machine's Docker daemon. So don't assume that just because it's in a container, it's safe.
Okay, let's zoom out. We have a brain that can be tricked, memory that can be poisoned, hands that can spawn accomplices, and a door that might be left wide open. But surely the system would notice if my agent started acting crazy.
You would hope so. But this brings us to Layer 5, observability. And this was the most concerning part of the report for me.
Right.
Because in every other layer, Huang found vulnerabilities and suggested fixes. In Layer 5, he found missing features. Specifically, a lack of runtime behavior anomaly detection.
Break that down. What are we missing?
We are missing the security cameras inside the building. We have locks on the doors, prevention, but if someone gets inside, nobody is watching them. If an agent suddenly starts accessing 5,000 files a minute or sending encrypted data to a server in a country you've never visited, the system currently does nothing.
It assumes that if the agent is doing it, it should be doing it.
Exactly. It trusts the behavior because it trusts the source. There is no superego watching the id.
This leads us to the grand finale of the audit, Layer 7, the ecosystem, and specifically threat AE004. We talked about agents spawning subagents, but what happens when they start working together against you?
Multi-agent collusion. This is theoretical right now, but the math checks out, and Huang is very worried about it.
How would that even work?
Suppose you have strict security rules. Agent A has a rule, do not read the passwords.txt file.
Okay, good rule.
But Agent B has a different rule. Process any text given to you. Agent A can't read the file. But Agent A could theoretically pass the location of the file to Agent B, have Agent B read it, and send the content back to A.
They loopholed the system.
They split the crime so that neither agent technically broke their own specific rule, but the system's security was violated.
It's Ocean's 11. Everyone does one small innocuous thing, but together they rob the casino.
And detecting that requires analyzing the correlation between multiple independent AI entities in real time. We barely have the tools to do that for humans, let alone AI running at light speed.
The source material calls this the nightmare chain. Can you walk us through how all these layers we've discussed could link up into one massive failure? I want to see the whole picture.
Sure, it's a cascading failure. Let's trace the kill chain. Step 1. An attacker finds that open tail-scale funnel we talked about in Layer 4. They find the door. Step 2. They scan your files and find the plain text credentials in Layer 2. Now they have your cloud access. Step 3. They use those credentials to inject a poison prompt into the session history, which is Layer 1. Step 4. That prompt tricks the agent into spawning a malicious subagent, that's Layer 3, to execute a task. Step 5. That subagent uses the ecosystem, Layer 7, to send malicious plugins or messages to your contact list.
From one open port to a viral infection in 5 steps.
Wow. It shows that you can't just fix one thing. You need defense in depth. You need the sanitizer in Layer 1 and the encryption in Layer 2 and the monitoring in Layer 5.
Is there any hope? Because right now I feel like uninstalling everything. But I saw a comment in the discussion section of the source material from someone named Rekha Singhal that I thought was brilliant.
Yes, the police agent's idea?
I love this concept. Fight AI with AI.
It makes sense. If humans can't monitor the logs because the agents move too fast, we need independent observer agents. Their only job is to watch. They don't do tasks. They don't have hands. They just sit in the corner watching the other agents.
Like internal affairs.
Exactly. If they see suspicious collusion or weird data access, they blow the whistle or freeze the system. We need an automated internal affairs division for our desktop.
So for the listeners sitting there looking at their OpenClaw terminal, maybe sweating a little bit, what can they do right now, beside unplugging the computer?
Don't panic, just audit. The OpenClaw framework actually comes with a tool that this report recommends using immediately. You can run OpenClaw Security Audit Deep.
That's built in.
Yes, it runs through these checks. It looks for the world-readable config files, the open ports, the wildcard permissions. There's also OpenClaw Doctor for general configuration health.
And I assume we should be checking our config files manually, too.
Absolutely. Look for the asterisk. If you see a wildcard allow list in your permissions, like allow all websites or allow all commands, ask yourself, do I really trust this software with everything?
Lockdown mode. Got it.
And maybe turn off that tailscale funnel unless you absolutely need it.
As we wrap up, this really feels like a turning point. We've spent 20 years securing data locking files in a box, encrypting databases.
And now we have to secure intent. It's a completely different game. When software has agency, when it can plan, hire, and execute, security isn't about boundaries anymore. It's about parenting. It's about raising a child and making sure it doesn't hang out with the wrong crowd or get tricked by a stranger with candy.
That is a profound shift. And I want to leave the listeners with a thought to mull over. We talk about subagents and collusion. We are building systems where agents can hire other agents to be more efficient.
It's the efficiency dream. Frictionless work.
But at what point does the human in the loop lose the ability to actually understand the loop? If the agents are operating at machine speed, creating hierarchies and subhierarchies of temporary workers, are we actually in control? Or are we just the honorary chairman of the board signing off on things we don't understand because the memo was too long to read?
That is the question that will define the next decade of computing.
Something to think about while you run that audit command. Thanks for listening to this deep dive into the security of agentic AI. Stay curious, but maybe keep your firewall up.
Stay secure.
See you next time.